Welcome to the deep dive. Imagine just one piece of defense tech that does two jobs. First, it gets your forces ready for the fastest threats out there, but then it actually becomes one of your most powerful weapons. It's a constant race, isn't it? Defense tech, staying ahead, adapting. It's everything. So today, we're diving deep into something really, groundbreaking from India. It's the new STAR missile developed by DRDO. Our mission here is to unpack what makes this thing tick. How does it manage this incredible dual purpose? What's the tech behind it? And what does it really mean strategically for India? You're going to find out why this isn't just, another missile off the line. It feels like a real strategic leap. But the big question for me is, how can one missile do two things that seem so different but are both, absolutely critical?
Yeah, that's exactly what's so fascinating here and what we're going to explore. It's really a clever piece of engineering, right? And a smart way to think about defense resources. We'll dig into the why of it all, why this approach, and maybe more importantly, the so what. What are the long-term implications for India? We want to give you insights that go beyond just the specification sheet.
Okay, great. So let's start right at the beginning. The name STAR, what's that stand for? It's Supersonic Target. Okay. And the developer is India's own DRDO, the Defense Research and Development Organization. Now, you mentioned this dual purpose, which is, I think, the really compelling part. Can you walk us through that, how it starts as one thing and sort of morphs into another?
Absolutely. So initially, STAR is conceived as built as a target drone. Its job is air defense training. But here's the really innovative bit. There's a plan, a specific design path for a future version to become a potent air-to-air combat missile. This isn't just about being versatile. It actually lets India leverage its training tools, potentially turning them into real combat power quite quickly. It adds agility, a more responsive defense setup.
That really is incredible flexibility. Okay, let's focus on that first role for a moment, the ultimate training target. You said its primary job initially is a target drone, training the Air Force, Army, Navy. How does this actually make training better than, say, older methods, especially with threats getting so fast and tricky these days?
Well, this is where the realism factor becomes huge. Look, older training missiles, they just don't really mimic what forces might face today. The STAR missile flies at over Mach 2.5. That's more than 3,000 kilometers an hour? Just to give you a sense, Mach 2.5 is, it's right in the speed range of many modern cruise missiles, the dangerous ones.
Right.
And what's really striking is it's not just fast in a straight line. It can maneuver. It can change direction, change altitude rapidly. So your forces get to practice intercepting something that genuinely behaves like a real supersonic cruise missile or maybe an anti-ship missile heading their way. And that kind of realism, it's not just jargon. In a real fight, that could absolutely be the difference between success and failure.
Yeah, it sounds like it properly closes that gap between the training range and a real combat situation. Okay, so now the really remarkable part. How DRDO plans to pivot this. Taking this training tech and turning it into, a weapon. When it makes that switch, becomes a combat missile, what's it designed to go after? What are the specific targets?
Right, so when STAR transitions to its combat role, it's aimed squarely at high-value assets, the really important enemy stuff. Think AOSES, those airborne warning and control systems, essentially the eyes and ears for the other side's air operations. And it's also designed to target enemy radars, ground-based or airborne, and critical communication nodes like specialized comms planes.
Okay, let's connect that to the bigger picture then. Why are those targets, AOSES, comms planes, why are they so critical in modern warfare? What makes them such important targets for a missile like STAR?
Well, that really gets to the heart of strategic air superiority, doesn't it? If you can take out an adversary's AOSES and their key communication links, you severely damage their ability to coordinate their forces, to detect incoming threats, even just to talk to each other effectively. They are, in many ways, the central nervous system of a modern air campaign. So having a capability to neutralize AOSES, that's a massive force multiplier. It can effectively blind and deafen your opponent. That's a game changer.
That makes total sense. You take out the eyes and ears. And the STAR missile, it's not just about what it hits, but how it does it. It's designed to launch from fighter jets. You mentioned the LCA Tejas. What about its reach, its range and altitude capabilities?
Yeah, the platform integration is key. So launching from something like the Tejas gives it flexibility. In terms of performance, the projected range is pretty impressive, somewhere between 55 kilometers and up to 175 kilometers. And altitude-wise, it can engage targets flying quite low, down to about 100 meters, all the way up to 10 kilometers high. So a decent envelope.
Okay. And you also touched on some technical tracking details.
That's right.
Radar cross-section, RCS, from zero point 0.2 to 1.9 square meters, and using common radar bands like SCX, KUA. For those listening, what does that RCS range actually mean, and why are those specific numbers and radar bands significant?
Right, good question. So radar cross-section, RCS, is basically a measure of how visible something is to radar, how much radio energy it reflects back. A smaller number means it's stealthier, harder to detect. So STAR being able to track targets with an RCS down to 0.2 square meters means it could potentially go after smaller drones or stealthier objects. And the upper end, 1.9 square meters, covers larger things like, well, surveillance aircrafts or AWACS. So it's versatile in what it can see and track. As for the radar bands SCXQ, using these common frequencies ensures it can work with India's own radar systems on the launch platform like the Tejas. And it also means it's designed to operate effectively against various types of enemy radars and potential countermeasures across a broad spectrum. It covers the bases, so to speak.
That's really helpful context, thanks. And achieving that kind of performance, that precision, that range, a lot of that comes down to the engine, right? Let's talk about this special engine, the liquid-fueled ramjet, or LFRJ. What makes a ramjet so different, maybe so advanced, compared to a standard rocket motor?
The engine. Yes, the LFRJ is key. It represents a huge step up in terms of efficiency. See, your typical rocket has to carry everything it needs to burn fuel, including the oxygen, which is called the oxidizer. That adds a lot of weight, a lot of bulk. Ramjets, however, are different. They're called air-breathing engines. As the missile flies forward at high speed, it scoops up air from the atmosphere. The shape of the inlet and the engine uses the missile's own speed to compress that air. Then it mixes fuel with that compressed air and burns it. So it doesn't need to carry its own heavy oxidizer. This makes the whole missile much lighter for the same amount of thrust, or allows it to fly much faster, or sustain high speeds for much longer, or carry a bigger warhead. It's about efficiency.
Right. So what does mastering this LFRJ tech really mean for India strategically? What's the so what here?
Well, the so what is pretty significant. The LFRJ propulsion points to a major advance in India's missile capabilities. Ramjet technology is really at the cutting edge because it enables sustained high speeds and much longer ranges compared to traditional rockets without those weight penalties. And it's not just about this one missile, STAR. Mastering ramjets is crucial for developing next-generation systems. Think longer-range air-to-air missiles, maybe hypersonic cruise missiles down the line. We know DRDO is also working on the Astra Mk3 missile, which apparently uses similar ramjet tech. So it signals a clear, long-term strategic direction for them. They're building core competencies.
Okay, so it's a foundational technology. Where does STAR stand right now in its development? What's the current status? Are there big hurdles at this stage?
It's currently reported to be in phase 3. So that means it's moved well beyond just concepts and initial designs. Things like the actual rocket casings, the nozzles, these components are apparently being manufactured now. In terms of hurdles for something this complex, especially with a ramjet, well, phase 3 is all about integration, making sure all these advanced parts, the engine, the seeker, the controls, work together perfectly, especially under the extreme stress of high-speed flight. That's always a challenge. The expectation seems to be for test trials maybe late 2024, possibly early 2025. And the plan seems pretty logical. Get it working, prove it out, then introduce it first into service for training, get the forces used to it, and then later roll out the combat weapon variant. It's a sensible phased approach.
Yeah, that tiered rollout makes a lot of sense. Okay, let's zoom out a bit then. Think about the big picture, its overall strategic importance for India. How does this one project, STAR, actually feed into multiple national goals? You mentioned readiness, self-reliance.
Yes, and that's what's particularly compelling, I think. This single project serves several key strategic objectives simultaneously. First, obviously, it significantly boosts the quality of combat training for the Indian Air Force, Army, and Navy. Better training means better readiness against real threats. Second, it gives India potential very potent indigenous anti-IOCS and anti-radiation missile capability. That enhances both their offensive punch and their defensive shield in the air. Third, beyond the weapon itself, it's about mastering that critical ramjet propulsion technology. That pays dividends across future missile programs, building deeper technological strength. And finally, yes, it fits perfectly with those larger national drives. Make in India, Atmanirbhar Bharat, self-reliant India in the defense sector. Developing this kind of advanced system domestically reduces reliance on foreign imports and builds up India's own defense industrial base. It really gets multiple targets, strategically speaking.
So, wrapping things up, DRDO's STAR missile, it really does sound like a remarkable development. a dual-purpose high-speed system. First, it simulates those tough supersonic threats for training. Then, potentially, a future version destroys high-value enemy assets from the air. It definitely marks a big step for India's missile and aerospace capabilities, doesn't it? Shows a real commitment to homegrown innovation and thinking ahead strategically. And maybe as a final thought to leave everyone with, just consider how dynamic this whole global defense landscape is. Things like the STAR missile really highlight that constant push and pull, that race between defense developing countermeasures and offense developing new ways to attack. It's this nonstop cycle where advanced training tools like STAR in its first role and cutting edge weapons like STAR in its second role are both absolutely crucial for national security. Makes you wonder, doesn't it? How might this ability to essentially transform a training asset into a frontline weapon change the way nations think about military readiness and buying equipment in the future? Something to think about until our next deep dive.